Let f of x equal negative 2x cubed plus x minus 4. What is the average rate of change of f of x from 0 to 3? Chloe is here with her latest cheat sheet notes. She wants you to know that the constant rate of change is the same as slope. You label one point x1, y1, and the second point x2, y2. So the constant rate of change formula, or the slope formula, is y2 minus y1 all over x2 minus x1. Now the average rate of change is like the constant rate of change. You label one point A and f of A, and the second point B and f of B. And the average rate of change formula is f of B minus f of A all over B minus A. Now that we have Chloe's cheat sheet notes, let's find the average rate of change of this function from the interval from 0 to 3. Now, when we're looking down here at her cheat sheet notes, she talked about the constant rate and average rate of change. Now, constant rate is slope. You use the constant rate of change when you have a straight or a linear line. When you have a curved line, you have to use the average rate of change. Now, both formulas are essentially the same exact thing. You take one term, the y value, subtract the y value of the second term in your numerator, same thing here. In your denominator, you take one term's x value, subtracting the other one's x value, same thing. So both formulas are the same. You just use the constant rate of change when you are looking at a linear or straight, and you use the average rate of change when you're using some kind of curved line. So we're going to go ahead and find our a f of a and our b f of b. So I'm going to start with 0. So my x is going to be 0, but what I have to do is plug that into my formula. So I'm going to take f of 0 equals negative 2 times 0 cubed plus 0 minus 4. 0 cubed is 0, and negative 2 times 0 is 0, plus 0 is negative 4. So when my x was 0, my y is negative 4. And I'm going to label that a, comma, f of a. So my a is 0, my f of a is negative 4. Now I'm also going to do this to 3 because the first part of my interval was 0, my upper bound was 3. So I'm going to go ahead and plug in 3 for x. So I have negative 2 3 cubed plus 3 minus 4. 3 cubed is 27. Negative 2 times 27 is 54. And negative 54 plus 3 minus 4 is negative 55. So when x was 3, y was negative 55. So I'm going to label my 3 b and my negative 55 f of b. Then I am going to go ahead and use the average rate of change formula, which is f of b minus f of a over b minus a. So again, it looks exactly the same as the constant rate of change formula or the slope formula. I'm going to take negative 55 minus 4, negative 4 on the numerator, and then 3 minus 0 in the denominator. Negative 55 minus negative 4 becomes negative 55 plus 4. 3 minus 0 in the denominator is 3. Negative 55 plus 4 is negative 51, and negative 51 divided by 3 is negative 17. So our average rate of change between these two is equal to negative 17. So let me show you what this looks like if we graphed it. So this orange line here is my f of x. That is negative 2x3 plus x minus 4. Notice how it's a curve. Now we were looking from the interval of 0 to 3. So here is where my x equaled 0, and 2, 3, this is where my x equals 3. So we're only looking from this point here, 0, negative 4, to 3, negative 5. So what I did is I took that average rate of change, the negative 17, that's technically the slope of the average. So if I drew a line through it, which I did right here, I drew the line through it, and I knew that my y-intercept was negative 4 because we had 0, negative 4. So I went ahead and drew a line through it. That is why we have to do the average, because you can't find a slope of a curved line. So what you're doing is you're taking the average from the first point to the second point. You're essentially, in your mind, drawing a straight line and finding the slope of that straight line. That's what it means to find the average rate of change.